we have discussed about database. So in today's video, we are going to discuss how we can optimize the database. What does optimization mean? Optimization means having scalable database, improve performance, improve availability, and other things which make the database efficient and more reliable. So how we can do this? We can easily achieve it with the help of two things. First one is indexing. Second one is partitioning of database. Partitioning of database. So let us discuss one by one. What does indexing mean? Suppose you have a very big database, okay, which has a millions of rows containing name, age, and gender, and I give you a task to find all the rows whose name are Ajay. So how will you find? You go and write a simple query. Select everything from employee table where name is Ajay. But how the database find it? Database will go search the first name whether it is Ajay or not, then go for second name, third name, fourth name, fifth name, and there are millions of rows. So he have to go for millions of iteration, and this is basically a time complexity of n. So you have 100 row, then it takes 100 iteration, 1000 row, then 1000 iteration, 1 lakh row, then 1 lakh iteration. This is the way. It is a linear search. But what happens if I make another table with the search query column? Suppose I always search from name, so I have a one column of name and second column of pointer or index, and this is sort. So when any data is sort, then searching takes linear time. Instead of linear time, it takes log time. Why? Because when there will be a search of sorting, we can search with the help of binary search. I hope you know what is binary search and how we can search through binary search. So when the table is sort, we can easily search anything with the help of binary search, and binary search takes log n time, and log n is very small than n. So the time taken for any search in a sorting is very less. So with the help of pointer, suppose we wanted to find the name of Ajay. So if everything is sorted, we can find it in a linear time, and with the help of pointer, we can easily find all the details of the Ajay. So this pointer or index help us to search anything very fast. So finding any type of query is very fast with the help of indexing. So with this, we can optimize our speed, we can optimize our performance. So we have to use indexing in all place? No, we can't use indexing in all place. Why? If there is a database which are reading intensity, we have to write one time and we are to search it many times. Then this type of indexing is very easy, because when we one time write it and sort the all the data, then we can easily find everything in a log n time. But what happens if there is any database which is writing intensive? We write very frequent time, and we search or find any query very rarely. So what will happen? When we write anything extra, we have to sort this table again for making it sorting thing. When we write again anything, we have to sort this data again, So whenever we write anything, adding anything or removing anything from this, or we can say whenever we make any type of changes, we have to sort this table again and again. So whenever any database or any table is present which is writing in this thing, we will never use index. A table which has a write intensive, we never use indexing. But a table which is read intensive, we always use indexing to speed up our query, to find it in a log n time, which is very less than the n time. I hope now this part is clear to you. Now second problem with database is that if suppose there is a big data, okay, which contain 3 millions of entry, so what will happen? The performance will get decreases and decreases, the speed will get decreases whenever we add a new database to it. So what will we do? We are trying to break our data into different smaller pieces and put into a machine, so that we can easily scale the product, increase the performance and many more things. So what is partitioning? Partitioning basically whenever we break the huge database into a smaller database, that is called partitioning. Why partitioning is important? Because partitioning helps us to scale the data. Suppose a machine has a limitation of storing a 3 million database. So if you have a 3 million, it is very good. Now if you add 1 million more database, what will happen? This one single machine cannot handle. So you break the database into smaller 1 million database and you store in a 4 database. So scalability is increasing, performance is increasing. Why performance increasing? If you break the data into smaller chunks, so it is easy for search anything, because if you use log n into 3 million or use log n into 1000, so time taken for 1000 is smaller than log n into 3 million. So if you store a data, less data in one machine, it is very easy for search any query, so performance get increased. Management also improve by managing smaller data is much easier than managing a huge database. So management also increase, and also availability also increase. Why availability increase? Suppose you have a 4 million database. If suppose by somehow this database gets crashed, so what will happen? You lose all the 400 million data for a temporary time. Suppose this server of this machine goes down for 10 seconds. So for 10 seconds, your whole system of 4 million database get down. But if you store this data into 1 million 4 machine, and if any one of this server goes down, so what will happen? For the 10 seconds, you lose only 1 million of the data, but rest of the 3 million is present. So availability get increased. Load also get balanced. Suppose any type of query come in a one single machine, then but if you divide all the database into 4 machines, so load also get balanced in 4 different machines. So load also get increased in partitioning based machine. So partitioning based machine is usually of different type. So let's discuss about some of them. First one is horizontal partitioning. What is horizontal partitioning? Suppose you have a 4 million database. So what will you do? You divide first 1 million into one machine, second million into second machine, third million into third machine, fourth million into fourth machine. On which basis you divide? You divide on the basis of ID, suppose. So it is very good, but it has some limitation. Why? Suppose you have a database of 4 million people and you wanted to divide on the basis of name. Suppose you divide that A to I name come on the machine 1, J to M into machine 2, N to Z into machine 3. What will happen? Suppose A to I has only 1000 name, J to M has only 2000 name, but N to Z has a 1 lakh name. So what will happen? Some machine get a huge data, while some machine get a very less data. So horizontal partitioning sometime may become disadvantage if you partition in such a way that some machine get a very huge data and some machine get a very less data. I hope now this doubt is clear to you. Next base is vertical partitioning. Suppose you have a very huge data, okay. Now instead of partitioning to the horizontally, you store one column in a one machine, second column in a second machine, third column in a third machine. Now you do this type of thing. This is called vertical partitioning. Vertical partitioning also has another variety, that is, suppose you have a Zomato like or Uber Eat like website, okay, food delivery website. So the food delivery website has a customer detail, restaurant detail, or has a booking detail, okay. So storing all these different entities into different table is also called vertical partitioning. But vertical partitioning has some limitation. What limitation it has? Suppose you wanted to make any query with the help of two different column. Okay. Now these two different columns store in a two different table. So you have to use join query, and join query is slower. So your overall speed becomes slower. And suppose you have a different table, you have a restaurant table, you have a customer table, you have a booking table, and you want to find the relationship between customer and the booking. So you have to join these two table. So for joining, the speed gets slower. There will be one problem. Second problem is suppose you have a customer data, you have a restaurant data, you have a booking details about each and every customer. Suppose there will be 1 lakh customer, 1000 restaurant. So entry of customer table will be 1 lakh, entry of 1000 restaurant table will be 1000. Suppose the booking will be have a 1 crore or 100,000, 1 million entities, 1 million entities. So instead of partitioning, this table has also huge table. So you have to again partitioning the booking detail into a different part. So in vertical, sometime you one time partition, again you have to partition to make the table further smaller. So these two are the basic problem. Now let's go to the other partitioning, that is directory based partition. What happen in directory based partition? Suppose you partition your data into 4 different machines, and now anyone come and search here. So how will it know that which machine it to go? First machine, second machine, third machine, and fourth machine. So what will happen? We come with a directory server, and it store all the detail which server has a which thing. So what will happen? Any request come to it, it find which machine it has to find the detail, goes to that machine. Okay. So it act as a manager. So all the requests come to here, it find the required machine and send that request to that machine. Okay. So what are the benefit of this? You can easily horizontally scale this product. Suppose you have extra data, so you can add one more machine to it and give that detail to the directory server, and it can easily give you the data. Second thing is, all the things are loosely coupled. What is meant? The server request directly does not goes to a machine, whether it goes to a directory from where it goes to a machine. So it is loosely coupled. But there are some problems. Suppose the directory server gets down or any problem happens. So it has a single point of failure problem. That is the main problem of this server. Now we know about the partitioning, but on which basis this partitioning happened? The partitioning happened on the basis of 3 different criteria. So let us discuss each of one of them. First one is round robin partitioning. Suppose you have a 3 million database. Okay. So in round robin, what will we do? Suppose there are 4 machines. So first goes to this, second goes to this, third row goes to this, fourth row goes to this. This is called round robin. Round robin. Again, another one is list based partitioning. What will happen? Suppose you have a 1 million database. Okay, you have 4 machines, and each one has a ID. ID. So what will you do? You send 0 to $250,000, 50,000 ID to here to 5,000. Okay. Suppose by this, if you partition your database, this is called list based partitioning. Another one is hash based partitioning. What will we do? You have a database, suppose name, age, gender. What will you do? You make hash of name. Okay. You have 4 machine, so you will modulo 4. You get either 0, 1, 2 or 3. If you get 0, if you get 1, if you get 2, if you get 3. This. But this hash has a very big problem. What happens? Suppose you add one more machine. What will happen? Instead of modulo 4, you are doing modulo 5, and due to which your whole partitioning get disturbed, because suppose you want here from any data retrieval. So now what will happen? You again go to this name, but instead of 5 machine, now you store the data with the help of modulo 4, but now you retrieve the data with the help of modulo 5. So your hash function will get the wrong input. This is a very big problem. So how will you solve it? You solve it with the help of consistent hashing. So what is consistent hashing? Let us discuss about this. What happened in consistent hashing? That you take a circle and you have 4 machines. So you divide circle into 360 parts. Okay. And you store 4 machines into 0, 90, 180, 270. So what will happen? If any hashing, here what will do? Hash of name, but instead of machine we hash with 360. So if any value that come between 0 to 90 is stored in this, 90 to 180 is stored in this, 180 to 270 is stored here, 270 to 360 is stored here. So what will happen? Suppose any machine get failed, okay, suppose this machine get failed. So what will happen? All the data which we store into 0 to 90 will also get stored here. You will not going to disturb other data. I hope you understand it. This way you do not disturb the whole data, but only disturb the half part of the data where the machine get disturbed. And suppose you have a 4 machine. Now you wanted to add one more machine at 50. What will happen? Here what will happen? Before you store 0 to 90 hash number to this table. Now what will you do? You store 0 to 50 to this and 50 to 90 to this, and all the data which earlier stored here from 0 to 50 hash number will get transferred here, and you do not disturb other machine. By this way you achieve the consistent hashing. I hope each and every point of this chapter is clear to you. We will meet in the next video. Till then, goodbye.